make a good topic in that time frame. Is there anybody else that has something? Okay, that's good. So as people have ideas, feel free to send those to me through the mailing list. And if anybody's also interested in presenting at the regional summit, let me know about that as well. So I've already gotten contacted by a couple of people. So right now we're just trying to set up the size of or really the amount of hours that we would need in order to talk and try and get that reserved. So as people have ideas, let me know about it.
Hello, Steve. This is Rafael Garcia from Infineon Technologies.
Hello.
So in our case, Infineon would like to participate in these workshops with a topic about semiconductor technologies that can influence the design of power supplies.
Okay. All right. I think that would be good.
Can you repeat one more time that you said that in October will be the workshop, and between today and this event in October there will be another event? Can you repeat this, please?
So right now, yes. So right now there will definitely be an event October 1st and 2nd in Amsterdam. There's details on the OCP website. So there will be a rack and power engineering workshop there. And we also have the possibility to meet again between now and October. So we would, instead of having our monthly meeting over the phone like we're doing now, we would have another meetup somewhere. Like, for example, last year, the last one we had was in Dallas in the fall. So that's certainly a possibility. So that's really what I'm asking is, is there, I'm just trying to gauge the interest in people meeting face-to-face between now and October or in October. So, Rafael, in your particular case, are you more interested in meeting, say here in the U.S., or are you more interested in the summit, regional summit?
Could be both. Could be both. Because what we want to have is a face-to-face presentation, right? Where we present what Infineon offers in terms of power semiconductors, and then have interaction with the different parties involved in the design of power supplies. So definitely, it is absolutely for sure that we will participate in the Amsterdam one. In the other one, yes, if there is enough audience, yes, we can also participate.
Okay, great. Anybody else before we move on? Okay, great. So the other two, the next thing I wanted to talk about real quick is the Open Rack specification. So currently the revision is 2.0. There's some changes that have been proposed to update the specification to 2.1. Most of them are pretty minor. So one of them was changing the tolerance on the bus bars, and I believe there's another minor change that we kind of approved a while back. We haven't revised the spec for those. The other one that's coming up is we're going to add an appendix related to test specifics for EMI containment at the rack level. So it wouldn't necessarily change any of the specifics in the specification. It would just be a process and procedure for testing EMI at the rack level. So if there's any other proposals for changes to the top level specification, the Open Rack specification, let's get those sent in so we can get those discussed. And that's also a topic that I would like to bring up at the next engineering workshop. We can review the 2.1, whether that's in if that's in Amsterdam or if that's sooner. But just let me know if there's any additional changes that anybody would like to see to the specification as part of 2.1. So next on the agenda is kind of a detailed work discussion led by Michael Thompson and Richard on the Redfish profile that we've been discussing for the last couple of months. So Michael and Richard, do you guys want to give you guys the floor and let you take it from here?
Richard, do you want to go through your presentation?
Yeah, I prepared some very brief overview on this one.
Or just to do two separate bus tabs.
Okay, and
I want to talk with Tao to get his input on this.
let me just. Okay, I'm hoping that. Can everyone see my screen now?
We can.
Yeah, I can see it.
Yeah.
Yep. Thank you.
Okay, so just a brief presentation on DMTF Redfish. This slide just lists down their goals, and the key message here is that the API should be over RESTful interface over HTTPS in JSON format. Next slide is these are the Redfish design tenants. You can find both information in the Redfish DMTF website. So just glance over this tenants to set the direction for where we want to go. And then I think this slide is the important one, which is how I view the framework that we would be doing. So the outer square will be the rack, inner square will be the PowerShelf, and I'm hoping that the activity that John Leung is pushing would cover the larger frame, which would be the rack being managed by the hardware management team at OCP. Because I believe that at that level, there's a lot more involved other than power. So they would have systems and servers and all that. So I guess the group's focus will be what's mechanical probably or power related. And that leads us to the PowerShelf. And of course, there was a suggestion from Mike Thompson to look at PDUs, smart strips, and any other function that you can place in the rack, which would not be covered by the hardware management team. So we will be working on this definition. But the way I view it is we'll have the PowerShelf, we'll have the rack, then the PowerShelf, and inside the PowerShelf would be the power modules and the BBU modules. And of course, a lot of the things here, like the chassis, manager links, actions, events, service, would just be a repeat of the content on the rack level. Then as you go down, you get more granularity on the components and the resources available. So I guess the key message is on the next slide, where I've looked at the schema, power schema, and the objects available. So we would need to propose to add a PowerShelf schema, a BBU module schema, a PSU schema. A lot of the information is also repeated, and about 90%, 95% of the schema is already there from the from the Redfish API, and we would just need to add updates to power control and updates to have current as well. So the power object already has some components of voltage. It has power, but there isn't any information on current. And it will be obvious why we need the current later on when we discuss the BBU module object. Anyway, there's another Excel file that that I've been working on and doing my best to update. But that would give the details for the schema, and I've color coded the cells so that it will be obvious to everyone on what items that it's being proposed to be added. Any questions so far?
Yeah, this is Bill. A question. When you say that you need to update the schema, is this the Redfish schema that needs to be updated, or is it the OCP profile for power?
We can go about it in two ways, where we ask Redfish to update their power schema, or in my mind, we can also do it through the OCP profile, where when we do the mockup and the JSON, we will just include it there.
Okay, thank you.
And I believe this one is the last slide, and this is, I think, what the group will need to decide and define the expected out. And this is, of course, from my view, and others are free to chime in on what the expected output is from all of from this initiative. So I think at the output from the group would be a definition of the baseline for the rack and power profile. Does it make sense to have a tiered level, meaning, okay, we begin with the baseline and then you have a level 1 or a level 2 with, as you increase in levels, functionalities get added more and all that. But we make the definition that in order for you to be, how should I say, certified for the OCP profile, these are the minimum that you have to fulfill and all that. So I guess we'll make that decision when we fill out the list, and then we decide on the contents. And then another output would be the mock-up for rack and power. And I guess whatever the group comes out with, do we submit that to the hardware management group, and then they build up the bigger mock-up for the Redfish profile? Again, feel free to add any more outputs that you would expect from this initiative. So there are some ongoing actions. If you need to, I think Steve will be able to add your name to the email thread that is going around if you're interested. So we're reviewing the schema right now. As I mentioned, we have an Excel file circulating around, and we're basing off the baseline or the commands. I think we're just throwing all of the commands that we think we need to support, and then we'll go through that list and either add more to it or simplify it to define the baseline. Mike is working on preparing a JSON, and I believe I saw an email from Mike regarding the preliminary JSON. I also have a JSON that has been prepared by my team. I think we also have gone and did some mock-up already based on the PowerShelf. We've went through the Redfish validator. It seems that the mock-up is okay. It has passed the Redfish validator. what we're working on right now is we're comparing, or we plan to run it against the OCP profile just to make sure that what we prepared would match. And then, of course, there would have to be discussions about what do we need to add. There were already reviews with the DCIM draft specification, so we'll need to go through that document as well. I've glanced through that one, and it seems that there's a bit of there's a lot of maybe at 80 to 90% match as well with what we are doing. Okay, that's it. If you have any questions, feel free to ask.
Yeah, again, this is Bill. I have a couple. How difficult is it to in your mock-up to run through the Redfish validator? And really, is it a simple process that anybody that produces a PowerShelf should be able to pick up and execute on, or do we need to create a procedure to help guide a newbie through the process?
It was not as difficult as I thought. My engineer's feedback was that he just needed to go through the Redfish document. There's a lot of material available from the Redfish website. It was my engineer's first time to go through that process, and he finished it in about 2 to 3 weeks as a side job. So I think it was pretty straightforward.
That's good to hear. When you run through the validator, and I'm unfamiliar with the validator myself, but does it produce an output that says that it passes or like a go no go or pass fail criteria that we could use then to as an audit process for devices that have been tested against the profile? Yes.
I've looked at the output of that validator, and it does tell you what has passed, what items have passed, what items have failed. So it's pretty detailed.
Great. And then on the on the time frame, do you have a time frame that you're working for to release I'll call it a 1.0 baseline profile?
I have not gone through that definition yet, and I thought that it would be good to put it up to the group. If we can have a face-to-face, or if there's a plan to have a face-to-face in, let's say, July, August, I think by the July, August face-to-face, we should come up with that first draft for release. So that means we should be drafting or preparing documents as early as now, and then by the time that we get into the July, August meeting, we should just be voting or maybe fine-tuning the release. So yeah, I think if there's a time frame that I can put to it, maybe July or August would be a good target for the draft release.
The reason I raised the question is that because we have a regional summit coming up on October 1st, it would be nice to have the baseline profile released and give people time to actually test their PowerShelf against that profile and be able to use the summit to announce the results of some of that testing. We have other companies that are producing server sleds, compute sleds that are also interested in testing against the OCP profile or the baseline profile. And I think that along with the compute nodes, I think power is probably the second most important device to have tested.
Okay, then I think if we plan for July-August draft release, then I think that plays in well to the October workshop.
Yeah, I agree.
I think that's a good suggestion, Bill.
So, Steve, you also, I know you brought up the comment about the need to do a workshop. We do have a telecom workshop in May at the big telecom event, and so some of us will be in. I want to say it's either Austin or Dallas. I think it's Austin, Texas.
Yeah,
I think in years past that's been a decent location to meet, and I don't know that we'd have space or need to do it in conjunction with that telecom event, but doing something that same week in Austin may be a kind of a target time frame.
Yeah, I talked to Archana about that yesterday. I just don't know. It's coming up really quickly, so I don't know if we could get enough organized in that time frame exactly.
Well, this may be a topic, very focused topic that we could get people together that are passionate about defining this baseline and try to make significant progress here pretty quickly.
Yeah, absolutely. That's kind of why I'm asking, right? When what and when are people interested in meeting? And then I know the foundation is very, very helpful and getting us what we need when we need it. So that's really what we need from members of the community, right? So let us know what you need, and then we'll go make that happen. So if you guys think you would be ready to meet in in Texas in May, I mean we can definitely make that happen.
I think May is pretty soon, so there's a lot more that we have to do here, and I don't think May would fall into that time frame.
Okay, that's fair. That was my first thought, at least with a couple of these things that were just now kicking off. It might be a little bit too soon, but that's kind of information we need. So I definitely think that we need to add a few more components onto the list. I definitely think that we need power strips or PDUs added in, and I think even like fan walls, and I don't know if that's a separate component, but we also probably need a cooling, whether it's refrigerant or some sort of cooling door as well. So I don't know if the fan wall could fall underneath, basically be covered by a refrigerated door profile as well. But I think those are the ones that come to my head. Is there anything else that anybody can think of in terms of kind of infrastructure components that we need to make sure that we're providing coverage for?
Yeah, ASHRAE has already done a lot of work with the Redfish crew for like computer room air conditioners and chillers. So I would imagine that a lot of the sensors and resources that are on a air conditioner are exactly what you would need for a rear door cooler. So we could just borrow a lot of their work.
That would be super. I'm sure that's probably true. Anything else anybody can think of in terms of infrastructure components that aren't on this list? Okay. Michael or Richard, do you have any other topics or questions for the group?
Not yet. Not yet.
Yep, none from me. Yeah, if there's nothing else, then I think this wraps up the Redfish discussion.
Okay. Super. Thanks for the update. I think this is a very helpful introduction to what you guys are doing. And kind of like Richard mentioned earlier, if you want to get more involved in the details and actually see some of the files that are getting transferred around, just post something to the mailing list, and we will get you kind of added into that discussion. Either myself or one of the other members that are working on that. So thanks you guys. Appreciate that very much. So the next thing we've got on the agenda is kind of a similar detailed discussion on PowerShelf interoperability specification, led by Harry. So Harry, do you I'll kind of turn it over to you.
Thank you, Steve. Steve, I'm just trying to see. I'd just like to. Okay, I see the control here. You've been made a presenter. Show my screen. Okay, that's perfect. Okay, so well, thank you, Steve. So essentially, we started this off in the last session, and we agreed to form, start a committee on this one, especially for a PowerShelf level or the Power accessories. With the way this is evolving, the interop becomes a big issue. So, so I'm just, can everybody see my screen?
Yes, I can see it.
Okay, perfect. So what I'm trying to show here is the different challenges that we have all seen, at least, at Artisan, we have experienced over the past, when we start working on interop, where it's at a PSU level, we get into a lot of area difficulties in the former areas, like the current sharing, because everybody has a different approach to current sharing. Even though you may have the same reference voltages, but the rate of rise of those voltages, the way they come about, that causes an issue. We have seen that in the communication protocols, and the communication signals, that causes an issue. What's particularly interesting is the startup as well. So, so this slide sort of shows the challenges we face. So just talking about on a higher level. So when we design, I guess the key takeaway for us is we need to design with interop in mind. And what I mean by that is make sure that when we spec something, we understand the external environment. And I guess we get so narrowly focused on this that we forget that big picture. So I guess the objective might be to set a very high level of specs covering all common interfaces. So if I have a takeaway from this, what do we want to accomplish over the next few meetings and next few sessions is, we want to come up with a high level specs concerning the common interfaces. And what do you mean by those common interfaces is what is concerned with what comes into mind is, let's talk about the timing. That is a key for PSU or shelf operation. Hot swap, just a few examples. Interface, the circuit characteristics, right? So enable how the power supplies come up, the PM bus area, the timing specifications, right? So if we can conquer that, I mean, it offers advantages of openness, and it's for everyone. The vendors as well as our competitors. We all benefit because we all win with this. So it promotes designing with interop in mind. So so essentially we don't end up designing designs which are very specific and narrow. So I just wanted to open this with that discussion. So I just want to hear what people have to say regarding to this and their experiences.
Do you think that PM bus is, or do you have an opinion on PM bus versus CAN bus? I've seen both used in PowerShells from different vendors, and PM bus doesn't appear to be real time enough to do current sharing, but CAN bus might be.
Absolutely. I guess from what we are seeing, I'm sorry, who was that?
This is Phil Picorni with Penguin Computing.
Okay. Hi, Philip. Philip, yes, I guess CAN bus gives you the faster access, and I've seen a lot more people moving towards the CAN bus as the time progresses. So, I think CAN bus is probably another way to go, but PM bus is also being used. So that's a good point. Anybody else has a feeling about the bus, about the communication?
Yeah, we have the same experience. We make systems up to 24,000 amps, and we can only use CAN bus on these systems. They would have several hundred modules, and PM bus wouldn't work for those. PM bus works great for like server level power, that kind of stuff.
Right. I see what you mean. Yes.
Can CAN bus replace a sort of an analog shared load line? Is it fast enough and responsive enough to do that?
Well, if you're asking my opinion, I mean, we have definitely seen CAN bus for, to simulate the digital type of the current share information. Yes, I believe it's doable. I'd love to hear from other power supply related companies. I don't know, Paul, are you there to share your opinion, or anybody else?
So hi Harry, this is Samir from Facebook. We also use CAN bus between the supplies. Sorry, I'm a bit sick, but yeah.
No, thanks. Oh, thanks. It's great to see that affirmation. I mean, yeah. Sorry, please go on.
No, go ahead.
No, I was just seeing that, I'm seeing a lot of move towards CAN bus. So perhaps, I don't know, in definition, and once we get a polling, we could set up, in terms of communication, we could set up CAN bus as one of the platforms, and we can work on specifications around that moving forward. That's the only thing I was going to add.
Yep. So along those lines, if we had those standards, then presumably you could offload the management from an embedded management processor to maybe one of the nodes in the rack. That depending on if the management module is involved in the microsecond to microsecond management of the shelf, or is required to be involved, or if it's just a monitoring function, that monitoring function could be moved to a host in the rack instead of needing to be an embedded component with embedded firmware, and then we get the whole OpenBMC thing and yada yada yada.
Very, very good point. Very good point. It could certainly simplify things. So Philip, that's Philip, right?
Yes.
Okay, so perhaps I can reach out to you later on and sort of work on the framework around that. On this.
Yeah. I mean, my input is useful as a system integrator, but as a power supply designer, I would be out of my element. But yeah, I could certainly. I'd love to talk and brainstorm some ideas of where this could go.
Perfect. Mm-hmm.
Hey, a question. Phil, maybe you understand this, but what's the difference between a PM bus and CAN bus that makes it better for low latency, real time type application.
So CAN bus was. Let me speak to this, I guess, a little bit. I came from the automotive industry, and CAN bus was created by the automotive industry specifically for real time, sort of engine, transmission, chassis control, and it includes a bunch of reliability and message guarantees. So you can assign certain messages priority that have bounded guarantees on how long it'll take those messages to make it to the bus and be distributed. PM bus is a set of register specifications on top of I2C, which is designed to be cheap and an in-box kind of low-speed management interface for GPIO and stuff. And it's been a very successful bus. The I2C bus has. But I think if you talk to anybody who's had to actually practically implement I2C in a hot swap environment, they'll tell you it's about the worst bus to have to engineer around, and it has all kinds of weird failure modes, and it can just screw you up 12 ways to tomorrow. So in terms of if you have something that's real time, where we're talking about load sharing of power supplies, I think that's where the design goals of CAN bus fit better than the I2C design goals. And PM bus is a great specification and is absolutely something that we would want to implement, or that might be implemented as a side channel where you could get information in a standards compliant way, by referencing a PM bus standard for register definitions, how a power supply reports what its load is, in longer time scales like seconds to minutes, serial numbers, input voltages, output voltages, those things. So you might want to have both, but if you're going to be doing real-time control, CAN bus is going to be the bus you're going to want.
Yeah, okay, that makes sense. I remember years ago doing a PM bus implementation, we had to change the scheduler because of that. It was just they used a round robin scheduler, and it wasn't sufficient for real time. So there's actually two components, and there's probably an API definition that would sit on top of the existing CAN bus physical architecture.
Hi, this is Richard from Artisan again, and we would be very much interested to hear you guys out on the woes that you've encountered on PM bus. If you would know, I think we have folks in Artisan, and I being one of them, who is working actively with the PM bus committee as well, the standards body. So we would be very much interested in learning, getting some feedback from you on the problems encountered there, so that we can at least bring it up to the PM bus committee. But at the same time, I'd like to clarify the scope of the interoperability. I believe that the OCP goal is to be able to have vendor A at the power shelf level be replaceable with vendor B at the power shelf level, and at the same time, the power supply modules from vendor A and vendor B, you should be able to mix them up at the rack level with the host controller management and all that. They shouldn't even know that you've swapped the modules, swapped the shelves. I think that's the goal of the interop initiative. So to me, that means that what we have to worry about first is to ensure that the modules and the shelves would play nice with each other, and then we can expand the discussion to the host controller managers and all that, which I think once we have CAN, and I'm assuming that most of the power shelves nowadays would actually have an Ethernet or a CAN interface, then that really doesn't become an issue, because we would need to define the CAN support, but there would generally just be a translator from PM bus to CAN. I think that's another level of the interop, but I think the more immediate one right now is how can we ensure that the modules play nice? Because I think what Harry is saying is that if you have a module from vendor A and you try and mix that with a module from vendor B, then your output voltage, output current characteristics would be largely different from when you have similar modules from similar vendors. Just my 2 cents.
So, Richard, I think you raised a very good point. I know perhaps we get into nitty-gritty of things. I guess engineers being engineers, right? But you know, what we are talking about here is the communication, right? And you know how PM bus versus CAN bus and what definitions we define and the transmitter properties so that the communication is seamless. I guess that's what we want to get to at the end, right? So that's just one of those interesting things, and which leads to good discussion.
Okay, all right.
So thank you. Thanks everyone on this. I think that was a good discussion on that. And similarly, you know, if you talk about we talk about digital communication, current sharing, right, and dynamic response plays a key part on those ones. So let's for instance, you know, we perhaps don't want to get into nitty-gritty of current sharing, but we do want to write specifications on, you know, how is current sharing defined when you're working with different different supplies from different vendors, and how they behave and how are they tested, and we need to get sort of an agreement on that as well.
So I wanted to you know, about the PM bus and my comments about I2C.
Sure.
I'd make an analogy to, you know, what's the statement about democracy? It's the worst form of government except for every other one. And I2C bus is, and so similarly, I2C is a terrible bus, but it's except for every other bus. So they're not specific to the issues I'm describing are generic to I2C. They're not PM bus specific, and anybody who's designed I2C systems, I think, is somewhat aware of the challenges. So I'm not sure there's a whole lot of feedback to the PM bus committee specifically about issues, but it might matter if we tried to push PM bus into an area where it wasn't initially designed to work, right? I mean, it was designed to be a way for BMCs or systems to query the power supplies, and it's very effective at that. But we would want to be careful we didn't try to push it into an area where it wasn't its strength. It was my point.
Yeah, I 100% agree with
that. Very good.
Yep.
Yeah, very good point. Absolutely. I think that was a very, very good summary, you know, to round it off, that, you know, PM bus has its own place, and so does the CAN bus, right? And I guess for all the discussions we are talking about, unless I hear otherwise, we will be focusing on CAN bus, right, for this part, for the discussion involving shelves. So, and how we play nice with regards to that, I guess that's what we will need to work on. So that said, so we will set up that one of the discussion topics, and Philip will make sure that, you know, you're definitely a part of that discussion. And my question on just on the, I guess similarly, we will set up discussion on the current sharing and the other parts as well, which relate to the power, more essentially the power part, the power part, and timing as well. Timing is another thing, you know, how the different power supplies, because, you know, all the power supplies, let's face it, use different vendors, different components, and they all have, even though you can define the envelope, they will rise, you know, the turn on will be in so many microseconds, they all behave differently, and they all come up differently. And so we need to define ways how they come up and how are they tested. I guess that's another area of concern. Anybody else has anything else to add on that one? Anybody especially from the power community? Love to hear from you guys.
Well, this is Paul Smith with GE. I wonder whether it's what the advantages are to having interoperability between power modules themselves, I was looking at this a little differently and thinking that we would do it on a shelf-to-shelf interoperability rather than the really complex issues that start to get involved when you start looking at how one module might plug into a module from vendor A may plug into a shelf from vendor B. Then you start constraining the size and the pinouts and everything else to be able to be physically compatible as well as electrically compatible. If you limit it to interoperability at the shelf level, the power shelf level, you simplify things a lot.
I guess that's a good point as well. So Paul, essentially you are saying is the shelf has all components from vendor A, and how does it play nice with a shelf which is from vendor B, right?
Yeah, right.
But Paul, wouldn't that have the same challenges? Because if you look at the power on an aggregate basis, whether we're talking about 20 kilowatts of power versus a PSU module, which is a 3 kilowatt, wouldn't they inherently have similar challenges in playing nice with each other?
Well, yeah, the challenges are similar, but you're not introducing the additional constraint of physical compatibility as well as electrical compatibility.
No, yep. Perhaps yes. Perhaps the mechanical tolerances and all those things. Yes, those perhaps can be avoided. Yeah, I guess our mandate has been to look at so especially from the shelf, the rack level. Our customers would like to have PSUs from vendor A and vendor B, and they don't want to carry separate inventory, so that simplifies things for them as well, right? So they think, can I just plug this in? I mean, we've been asked this question multiple times. I want power supply from vendor A, B, and C. They all work seamlessly. So I guess that's one of the challenges we all trying to avoid in this as well. So I can break it down into two sections, shelf to shelf and PSU, as I just mentioned. So that's another subset of this. Any other comments?
Yeah, this is Pedro with Huawei. I think
Hi, Pedro.
so I mentioned early on about maybe having a discussion about communication and management, this kind of in the same vein. It seems like we're if we first decide what things are important, for example, current sharing, that's really owned by the shelf. I think that's kind of Paul's point. Shelf manufacturers like ourselves, we're handling all that ourselves internally. Really doesn't matter what bus we use. That's kind of all our business. I think if your point that you've had customers say we want shelf A and B and C, all the components to talk together, and then we're trying to figure out an interface for that. I would point you back to IP interface, right? The world's becoming IP. Everything from your water meter, electric meter, everything else is going to have an IP address. We shouldn't try to reinvent that with supporting even CAN bus or whatever. If we just make everything IP, everything has an IP address. We can get to a web page and do the kind of the non-real-time management, which is kind of my point. That I think maybe we need to separate the real-time kind of control and management functions, which have to be handled internally by the product, like current sharing and voltage regulation, all that other stuff, with just letting the operator know I'm functioning, I've got an alarm, I'm over temperature, whatever. Those are things that are not real time, right? And if it's not real time, they can just be packets sent through the SNMP protocol. Everything can handle SNMP really well. Again, it's such a ubiquitous standard. It's almost silly to not do IP and SNMP. So anyway, that's my 2 cents on that.
Okay, Pedro, very interesting point. So you are saying, okay, so on a shelf level, But how does that address the problem if, let's say, we take shelf from vendor A and shelf from vendor B, and they have different, so you said IP level and somebody else works differently, how would they talk to each other? Unless they have a common IP interface, right?
Well, yeah, that's the point. I'm thinking, like, again, if we're talking about a communication interface, eventually everything's IP, right? You know, we're leaving the building in IP. You know, you're managing it. So the question is, how far down do you push the IP? And what I'm suggesting, particularly with the Internet of Things and the way things are going, the hardware, the software, everything is so well developed that you can push it down to the rack level, right? Every device on the rack has an IP address. They can talk to each other if they need to. They can send SNMP messages back and forth. SNMP protocols are really easy to manage. And again, all the layer 2 stuff, you know, getting the, you know, the syncing and the packets and stuff, that's crazy easy, right? And then, you know, you're at the layer 3 with the protocols. And so again, that's kind of what I was imagining we would be discussing at, you know, kind of a face-to-face, you know, where we hash this stuff out. Like, how far down do you push the IP interface? And then how much control is left basically to the individual devices to just do on their own? They can do that with CAN bus, PM bus, whatever it is they want to do.
Yeah, no, I like your point, Pedro, of face-to-face discussion, because it's better to do on a whiteboard or whatever, work it out. Because, you know, I would pose a question. I know perhaps we're getting into nitty-gritty. That's all good. Everybody can have their IP addresses, but you still need a current ramp. You still need a voltage ramp, you know, in order to do that, right? I guess perhaps that's getting too detailed. And I don't know, perhaps we can set up a separate meeting to break it down into different sections. And, you know, I like this idea of the IP and how how it can have its own subsets to address the technical problems and the technical challenges that you might have.
Yeah, like I said, I think if we separate the things that we want to find out, the kind of communications we're talking about, you know, write them all down, right? Whatever they are, voltage sharing, alarms, all that kind of stuff. We can separate into things that are really hardware related that I need to address at the hardware level, and things that are informational that need to kind of go back up and forth to the user level, right? And then that'll kind of define which things need to be on the IP bus and which things need to be on an internal bus.
Very good point. I'm trying to take notes as we go on. Okay, good. Any other comments from anybody?
This is David from Facebook. Can you hear me?
Yes, David, very clear.
Okay. I think there are 3 things for this interoperability initiative. Right? First is to define the requirement. I think the requirement is very simple. We want as a customer, we want the TSU module and shelf can mix match with each other in the same rack or in the same shelf at module level. So that's the requirement. And there are two other things. The second one is there's like a design guideline or design spec, how to design the power module or shelf to meet this requirement. The third thing is the testing guideline, how to evaluate from testing perspective the modules and shelves. Another comment is on the sharing control. From the history in the industry, there's sharing control is all done by not going through the communication bus, but through a dedicated sharing bus. Mostly is analog signal. Okay, so the communication bus is kind of slow for the sharing real-time response. That's what we are with our current power supply vendors. So using the communication CAN bus for sharing control is a different topic. Yeah, it's beyond our current design. That's all my comments.
Thank you, David. You bring a very interesting perspective. Very interesting because we did hear from the others. Said okay, the shelf could be from one vendor, but hearing from you, this is exactly what I was trying to address: a mix and match on a shelf level and how we address it. So just you just pointing out to the challenges we face, and as a team, we need to address. And thanks for confirming that.
Right. Okay. Then we can work on the details. How to define the design guideline for how to design the interoperable power modules and shelves. How to test them. Yeah, we can define the detailed requirements in each of the sections.
Yep. So I guess, David, the first thing we need to start with is your specification and your requirements, and the interop has to work around. Interop has to work around it.
Right.
That's a good point.
Right. Okay.
Thank you. Any other comments? So I guess, Steve, I'll hand over the control back to you. We have our clear homework, and we heard from everybody else. We heard from power supply makers, and we heard from customers. So everybody's expectations are different. So we will need to frame it up and see how we can address the interop moving forward.
Okay, thank you, Harry. So based on the kind of work that you have to do now, do we want to wait a full month to have another discussion as a group, or do we think we need to get together in the meantime to have another discussion, say another 2 weeks? Just from a timing standpoint, when do we need to have another touch point to kind of go through people's deliverables?
I think sooner than later. That's just my opinion. And seeing all these things, I don't think we can wait a month. I think 2 weeks probably is better.
Oh, okay, I kind of agree as well. So let me take the action item to go set up a meeting for this particular kind of subgroup in about 2 weeks. So I'll work with the foundation to get that set up, and I will report that out to the full mailing list so that everybody has the details if they would like to join. How does that sound?
Sounds good. Thank you. Thank you for arranging that.
Yep. Yeah, no problem. So that's good discussion. So thanks everybody for your participation with that. So that's all the stuff we have on the agenda today. We've got a few more minutes left. So if anybody has any other topics they would like to discuss or questions or whatever, I'm happy to hang out a little bit longer and cover those. If not, we can go ahead and drop off. So anything else? All right, I think that's good. So thanks everybody for your participation. I think this is a great meeting. We're making some good progress, and I will make sure that the notes that I took on the items for today will get posted out to the mailing list. And I guess we will talk again either in 2 to 4 weeks. All right. So thanks everybody. Bye bye.
Thank you. Thank you. Bye.
Thank you.
Thanks.
Take care now.